Alright, so for my final video for this section, one other thing that I wanted to show you guys, this is the last type of problem I might give you with trigonometric equations, is something that looks like this. So what I want you to do as I'm writing this down is think about what's different about this problem than any of the other ones that we've done when we first started solving trigonometric equations. Okay, so let's go with cosine of 3 theta equals 1/2. Okay. If you look at this, what's different about this problem than any of the other ones that we've seen is that instead of having just a theta, I have also a 3 out here. Okay. So what I'm about to show you right here is specific to only problems where you have a 3 out here, or a 2 out here, or a 4, or a 5, or 6, as opposed to just a theta by itself. Okay. We're going to start out this problem the same way as we do any other trigonometric equation problem. So the first thing that we'll do is we'll decide we're working with cosine and the value for our ratio is positive. So which quadrants are we working in? And remember, cosine goes with x, and if cosine goes with x, that means we're working in quadrants where x is positive because our ratio is positive, which means we'd be in the first quadrant and then we'd also be in the fourth quadrant. Okay. And if you draw, 1/2 comes from a 30, 60, 90 triangle. If I draw a 30, 60, 90 triangle, 2, 1, root 3, this is 60 degrees, this is 30 degrees. Okay, the angle that has a cosine value of 1/2 would be 60 degrees or pi over 3. So both of these angles right here are pi over 3 angles. Okay, now here's where this differs from any other problem that we've seen. Okay, the angle in the first quadrant, I'm going to make a note, is pi over 3. And the angle in the fourth quadrant, that's a pi over 3, would be 5 pi over 3. Okay. Now keep in mind that when you do one of these problems, the solutions, or sorry, the directions say solve for all possible values between 0 and 2 pi. Okay. Now, when we did a problem in which there was just a theta, okay, these were our two answers, pi over 3 and 5 pi over 3. And the reason why those were our two answers is because those two answers are between 0 and 2 pi. Okay. And I kind of addressed this in class. I said the reason why I'm putting these restrictions on here is because if I started at pi over 3 and I took another trip around the circle, well, now I would be at 7 pi over 3, because make a note here, pi over 3 plus 6 pi over 3, that's one trip around the circle, gives me 7 pi over 3. Okay. However, I'm not going to include 7 pi over 3 as one of my answers, even though it gets me to the same spot on the circle, because 7 pi over 3 is bigger than 2 pi. Okay. However, what we see is if I didn't put this restriction between 0 and 2 pi, some additional answers to this would be like pi over 3, 7 pi over 3. If I added another 6 pi over 3, that would be 13 pi over 3, 19 pi over 3, etc. Those would all get me to the pi over 3 angle in the first quadrant. And then for 5 pi over 3, if I added 6 pi over 3 to this one every time, I would have answers like 11 pi over 3, 17 pi over 3, 23 pi over 3, etc. Okay? Basically, there's a pattern here. Okay? What I'm doing every time, if I wanted to get to these same two spots on the circle, no matter what I could do is I could take these answers that I've written right here, and I could add, pattern-wise here, plus 2 pi times a number. Okay, and we'll call that number n. What n means is that's just how many trips I take around the circle. Okay, so n could be 4. If I did 2 pi times 4, that just means I took 4 trips around the circle, and then I go to pi over 3. Okay, and the same thing would happen here. You could do a 5 pi over 3 plus 2 pi n. Again, you could pick n could be negative 10. All that means is I would take 10 trips around the circle clockwise instead of counterclockwise because it's negative, and then I would go to 5 pi over 3. Okay, now the reason why I don't do this part when I'm working with just theta is because if I was working with just theta and I plugged in like 1 for n, Well, 2 pi times 1, that's 1 trip around the circle, plus pi over 3, that's already bigger than 2 pi. Okay, so there's no reason in me doing this if there's not a number out in front of theta over here. Okay. However, in this particular problem, there is a number out in front of theta. So what I did was, instead of solving for theta, when I wrote these two answers right here, I actually solved for 3 theta. Okay. And because I haven't solved for theta yet, what I need to do to solve for theta is I need to multiply both of these equations that I've written by 1/3 to cancel out that 3 on the front. Okay. When I do that, here's what I get. Theta equals pi over 3 times 3 is 9. Okay. And then 2 pi divided by 3 times n. Okay, so there's my first solution. We're going to make a list here in a second. And then my second solution would be theta equals 5 pi over 9 plus 2 pi over 3 times n. Okay? Now, if the restrictions on this problem are I have to write every single possible answer that's in between 0 and 2 pi, what I need to do is I need to take these two solutions that I have right here, and I need to make a list where I find all solutions between 0 and 2 pi. Okay? And here's how we can make that list. Okay? I'm going to come down here. I'm going to start out with this first list. Okay? Remember, for n, we can plug in any number in the world that tells me how many trips around the circle I'm going to take. Okay? Let's say I just plugged in 0 for n. Well, if I plugged in 0 for n, pi over 9 plus anything times 0 is 0, so this would just be pi over 9. Okay? Now, if I plug in 1 for n, as long as when I do the math here I get a number that's less than 2 pi, I need to put this in my list. Okay? So what I need to do with this is if I'm going to take pi over 9 and I'm going to add 2 pi over 3, I need to find a common denominator. So I'm going to make a little note here that says 2 pi over 3 is the same thing as 6 pi divided by 9. Okay? That'll make it easier for me to add these numbers here. Alright, so let's try it. If I took pi over 9 and I plug in 1 for n, I'm going to take pi over 9, I'm going to add 6 pi over 9. That gives me 7 pi over 9. I'm going to keep this in my list, and the reason why I'm keeping this in my list is because this is still less than 2 pi. Okay? And what you'll see is if I add 6 pi over 9 again, or in other words, if I plug in 2 for n instead of just 1, I can add 6 pi over 9 to this as well, and I'll get 13 pi over 9. And that needs to go in my list as well because that is also less than 2 pi. But what I see is if I add 6 pi over 9 again, 13 pi over 9 plus 6 pi over 9, that gives me 19 pi over 9, which is bigger than 18 pi over 9, and this is 2 pi. Okay? So I'm not going to put 19 pi over 9 in my list. I'm going to stop at 13 pi over 9. Okay? Now, I'm not done yet because I still haven't accounted for anything that's in this list right here. Okay? So now what I need to do is I need to move to this list, and I need to find, can I find any solutions that are in between 0 and 2 pi from this right here? Obviously, 5 pi over 9 works. Okay? Now, if I take 5 pi over 9 and I add 6 pi over 9 to that, 5 plus 6 gives me 11 pi over 9. And I'm going to keep that in my list as well because that's also less than 2 pi. And if I add 2 pi over 3 again, I get 17 pi over 9, which is also less than 2 pi. But, just like last time, if I add 6 pi over 9 one more time, then I would get 23 pi over 9. And that's too big for my list because it's bigger than 18 pi over 9, which is 2 pi. Okay, so I'm not going to include 23 pi over 9 in my list. So when I'm done, what I end up with here is 6 different solutions that all fall in between 0 and 2 pi for this equation. Okay, so I'm going to circle these 6 solutions. And again, the only time that you need to do this process is when there's a number in front of theta that is not a 1. Okay, most of the time you're going to have a 1 in front of theta. In this particular case, there's a 3, which is why I set up this list where I took my answers and I added 2 pi in to represent however many trips around the circle I'm going to take to get back to the exact same spot on the circle. Okay. Once I did this, I took this answer, I divided it or multiplied it by the reciprocal of whatever this number is out on the front of theta, and then from there I took this answer and I created a list that had all the different angles that satisfied these two equations that were in between 0 and 2 pi.